Welcome to Executives at the Edge, a podcast brought to you by MEF. I'm your host, Pascal Menezes. Join me as we explore thought-provoking perspectives from the leaders and changemakers who are propelling enterprise digital transformation forward. I am so really excited to have Charmond Tsang and Paul Parker from DCConnect Global. And today I think you're going to find a very, very interesting episode on blockchain technologies and how blockchain is being used in a different way for interconnecting data centers and optimizing the path, route, and cost, and doing that at very rapid speeds versus each party trying to talk to each other to figure that out. So Charmond and Paul, welcome to Executives at the Edge.
Oh, hi, Pascal. Thank you for having me here. My name is Charmond Tsang. I'm the CCO of DCConnect. So what I do is I'm responsible for the business and commercial side of the company, and we do a lot of partnership and seek to develop our services and product into different markets. So far since our relationship and partnership with MEF, so it actually really helped us to leverage MEF resources and help us actually to go to different target industry, target continent for us to meet a lot of new partners. So once again, thank you for having me here. So I appreciate this opportunity to have this chance to talk to you, Pascal.
Of course, pleasure is ours.
Hi, Pascal. My name is Paul Parker. I'm the principal architect for DCConnect's Televerse project, and I'm looking forward to your questions.
What does DCConnect do?
Well, we are a software company and a network service provider. So in a way, we do two things. Where we are an NAS provider, and we are also a SaaS provider. Because we run and build our own network infrastructure, we build POPs around the world. We have our own backbone, have our own connectivities. And at the moment, we have over 1,000 POPs, SDN POPs globally. It's all run on the SDN platform. And then we also interact with a lot of different API partners through the LSO API. Now, and because of our ability to interact with a lot of different partners through the LSO API, so it actually really helps us to leverage, increase our footprint of coverage very rapidly. So we can manage to increase to over 1,000 POPs just in 3 years. So it's something that not a single carrier that can do. It only can work this way through partnerships. So DCConnect, we just not just only selling connectivities, but we also license our software through a SaaS model to build players that are interested to use a software platform to offer SDN NAS services. So that's basically what we do.
In the Red Forest, it's a Televerse DAO project. What is the rationale by choosing decentralized over centralization? And maybe just talk about this project, Red Project, and the Televerse DAO. I mean, people don't even know what DAO is. Let me just give a little bit of background.
Okay, so the progression here is that as DCConnect grew, we took on partners who allowed us to use their infrastructure. So we SSH into their switches, we configure them and use it for our customers. And from there, the next reach was to use API partners, which is all well and good. But even with the leveraging of MEF, LSO, Sonata, and things like this, the process of integrating with an API partner is still a unit of work, and it's a substantial unit of work. So Televerse is our effort to move away from that model onto a model where one unit of work gets you onto the network. So you're able to interact with multiple carriers, service providers, just from one unit of work, instead of having to do that work many times over for each service provider. You do it once, and then you've got connectivity to maybe 20 service providers in one hit. DAOs. Okay, so a DAO is a relatively new concept. The criticism of DAOs to date is that they haven't been very practical. So you can point at 10 projects that have failed in that space. The ones that do persist are those ones that have immediate monetary value. So you're looking at things that that exchange currency on the internet. The use cases for business haven't been so successful. One of the reasons for that is that public blockchain isn't good for business. The fact that you have to expose your private data in a public forum, a lot of the time that can be dangerous. Any effort you make to obscure your data tends to be somewhat of a hack. The answers to those questions, however, have come relatively recently. So we've got new technologies like zero-knowledge EVM,
Exactly.
ITM.
Baseline protocol.
These are opening up this space. So we don't have to have private blockchains, which was the alternative in the past. We can have public blockchains with private zero-knowledge EVMs that allow us to share secrets, our commercial secrets, amongst trusted parties without exposing it to the public, but allowing the public to verify it, and that's very powerful.
So for our listeners, the acronym DAO, Decentralized
Autonomous Organization. That's correct. Yeah.
Okay. And what does that mean? Because I'm not sure it's a very well known.
Okay, so the concept here is the analog would be a company. So a company is not an autonomous organization. It's an organization that has legal structure. A DAO, on the other hand, has coding structure. So the operations of a DAO mirror the operations of a company, except that they are coded. If you try to make some change unilaterally, that's impossible. The code will reject it. We try to build in mechanisms within the DAOs to allow some flexibility. It's still an area of research that's still very much in its infancy. The movement now is towards DAO templates. So basically collections of code that have been audited and allow us to spin up DAO structures with that kind of confidence behind them.
Okay, and why the rationale between decentralization and centralization?
Okay, so this comes back to the question before. If you want to collaborate with many business partners at the same time, either you have to trust one big business partner to build up the centralized infrastructure. One example would be something like Diners Club. So when Diners first came into existence, it was really just solving one problem, and that's the problem of rich people going to restaurants and not wanting to use cash. So the Diners Club card was born. That's obviously a centralized solution, and it works because you had that one player in town kind of situation. If, on the other hand, we'd had a situation where we had many different competing platforms trying to create the same thing, I don't think it would have been as successful. When it comes to telecommunications, everyone's on a level playing field, really.
So on top of what Paul has just said, my view is initially the tier 1 players, they don't like the ideas of decentralization. But I think the early adopter or the DAO network will be those tier 2 players, or those which are very innovative, very adaptable to new technology, and they are willing to transform themselves into a new way to offer the telecom services. But as long as the momentum grows, we will start to build a community in the decentralization organization. So a lot of players which are part of the community become the members. They contribute to ideas, right? And they will be very active in participate in the DAO environment. Oh, in this case, when the community go bigger, the network resources of the decentralized network will increase. And at that time, I believe the tier 1 players will start realizing that, hey, this is a market that they should not miss. So eventually, the tier 1 player will join the decentralized network later on. But even they're not the first mover, but I believe in the future they will follow.
And you're seeing tier 2 providers actually see that they have to be on the innovation cycle, they have to be leaders versus the tier 1s. Because tier 1s generally can be slow, but they have the reasons and the business reasons. I mean, most of the time they're looking at blockchain now for just, as they rely on their partners for elastic capabilities. They have to, build and settle on that. So that's like the top of their mind. But you're using a very different approach. So maybe can you maybe help our listeners with that?
Okay. The problem we are trying to solve is to make sure that all the resources available are being used and utilize that in a better way. So there's a lot of ENNI, which is network-to-network interface, available in the world, but they are not public information. They are the information between two carriers. Now, if you can imagine that if we can know all the single ENNI information in the world, and all the pricing information between all the ENNI. So in this case, we are able to create a network map so that we can calculate the best network path for a certain requirement. But in order to do that, right, we are some challenge that we have to overcome. Some carrier might not want to share their commercial company information, such as the ENI locations, such as the pricing information. But with the Red Forest Tellers project, we have a mechanism, we have an idea and to how to solve it. If we manage to do that, so what outcome will be? So there will be a network of resources which the DAO will have the visibility. So in this case, we can utilize a lot of resources. Now, those resources may come from tier 2 players, right? They might not be the tier 1 players. So in this case, tier 2 players and tier 1 players, suddenly they are in the same level playing field, right? The DAO can pick the best resources from anyone who contribute into the network. So in this case, tier 2 player will be very happy to be the first adopter to the Televerse DAO.
So let me put the use case together here now. See if I got this right. So you have a decentralized blockchain, basically. So it's using blockchain technology. It's a public blockchain, right?
The proofs are put back to the public blockchains.
What you're trying to do is in the DAO is basically you have these entities that participate in that, and you are now exchanging ENI informations between each other. And then from there, you can then calculate the best path to go from two different entities or companies that needs services provision, correct?
That's correct.
Is that what I got right? And now, why on a centralized database? Because someone would have to own that, run it, have visibility into it, like an identity provider model.
Exactly. We need a point of trust. So you need to trust the person that you're giving your information to. Exactly.
So that's the key point. No one wants to trust a central database, but all yet sensitive data into it. With the decentralized blockchain approach, everybody controls their own, sees their own, and until the query, then only thing is the output of what they asked.
Exactly.
That makes a lot of sense. Just want to connect the dots for our listeners. So, okay. Oh, thank you. So basically, what constitutes the primary innovation then of the Televerse DAO project?
The key innovation here is that each of the service providers have their own node, they control their own data, and they only reveal as much of it as they need for any particular commercial activity. So if they need to produce a circuit, the only service providers they need to share with are the ones that are party to that circuit.
Got it. And for our listeners, because I think this is a great topic, what exactly public blockchains, what's exactly the problem, and how does zero knowledge proof solve this?
So if you want to store a proof that you're doing this business, this commercial activity on a public blockchain, you have to have that information stored on the public blockchain. If, for instance, we want to use another technical term here, the EVM. So we want to use Solidity contracts to calculate out the routes. We have a big problem because anything that the EVM can see, anybody can see.
EVM, Ethereum Virtual Machine.
Yes, exactly. So the Ethereum virtual machine is not great for hiding these kind of details, and that's where the zero knowledge EVM comes in. The zero knowledge EVM is an evolution from zero knowledge rollups, if anyone knows what that is. In the past, zero knowledge rollups were relatively limited. You come up with an algorithm and you devise a means of sharing that the operation of that algorithm is correct, you devise a means of demonstrating that probabilistically to an observer. With the zero-knowledge EVM, what we're actually doing is proving that a Turing-complete mechanism is doing that. So basically, we're fitting every possible calculation that we could do into this new zero-knowledge EVM context. And that means that we don't have to worry about coming up with our own algorithms for proving something in this zero-knowledge rollup context. We can do everything on this zero-knowledge EVM machine, and there's no roadblock.
And in the EVM runs a smart contract?
Yeah, it runs the DAO. So the smart contracts that make up the DAO are inside that zero-knowledge EVM. Great.
Now, is the actual data stored in that smart contract in the blockchain, or like in the baseline protocol, you don't store that data, you store it on your own?
That's right. You store that data on your own. There are certain levels. So for instance, membership and things like that would be in the zero-knowledge EVM, but not publicly available.
Well, I think this is a great tutorial for our listeners on blockchain, and certainly a great use case, of course. And I think we're about to wrap up, but I got a good question. ChatGPT is being, the rave now recently. And is it possible for ChatGPT or other AI technologies to interface with this project? And if so, what might be the use cases?
Okay, so we're often talking about super users for Televerse, and a super user is defined as a user that doesn't really exist yet. They're people with coding knowledge and a need to move data quickly and flexibly, so being able to produce circuits quickly. From my perspective, ChatGPT itself is not very useful, but an AI that we train specifically for this use case could be useful.
To recap, this is about a decentralized blockchain approach where data is stored indirectly. Everybody stores their own direct data indirectly. And then from that, in this organization's DAO, parties can then go and figure out how to connect between each other in the most optimal way. And using AI technology assists on that. Well, again, I want to thank you, Charmond and Paul. And it sounds like this is a really great, innovative use case for blockchain. This is really awesome. So I want to thank you for your time.
Thank you very much for having us, Pascal.
No worries. Thank you.